Hi, this is my xOSC project, which is a bird simulator. It will produce 8 sounds with different interactions. The intent user of this project is for all ages. First, 0 of xOSC was used. When the xOSC is tilted left, wind sound is produced. When it is tilted right, it produces a lower toned wind sound. Both sounds were recorded with GarageBand. When it is tilted to the front, it gives ambient sound of a forest. When it is tilted to the back, it produces a sound of birds chirping from distance. It creates the view of the bird flying up, far away from other birds. A slider was used to trigger the sound of bird flapping. An image will be shown on the MaxMSP pitch. A light will turn on to tell the people controlling the xOSC that the image of the bird with spread wings is shown successfully without looking at the MaxMSP pitch. Other than a slider, a button was also added. When the button is triggered, it will give a bird chirping sound. Apart from that, a light sensor is used. When the sensor is covered, a bump sound will be produced. It represents that the bird hit on a tree. Lastly, a force sensor resistor is added. When force is applied to the FSR, it will produce a leaf rustling sound. It represents the bird pulling a leaf from a tree. Let's move on to the MaxMSP pitch. At the left side, it is for the gyroscope of the xOSC. Both x and y values were used. With the x value, it produces a wind sound when the xOSC is still left and right. For the y values, it produces ambient sound from a forest, one nearer, one from distance. Then it is for the slider and the light. By applying the fpic and alpha function, when the slider is on, image 1 is shown. When it is off, image of a bird with spread wings is shown. The next one is for the button. Then the light sensor and the FSR. Project is inspired by the workshop for a motion sensor. Not many examples of xOSC and MaxMSP were found. This is a video about using an Arduino breadboard to make an RC car. It inspired me to do a simple version of a driving simulator. Then I did a bird simulator instead, as I can use more sensors and produce more sounds. This project utilizes user-centered design, as user can only interact with a button on the breadboard. Images of a wing and a leaf were attached to show their functions. The light sensor is stick between cardboards to represent the eye of the. Also, resistor was added to the light to prevent the LED circuit from shorting out. According to the Ohm's law, V equals to I times R. Without the resistor, R current will flow through the circuit. It will lead to short power. Same for the button and the FSR. Besides, Nelson's response time law is applied as this project is a real-time responsive system. When the button is pressed, the bird chirping sound is caused. This applied to the response time law. This project is quite successful and it is exactly what I want it to be. It makes the user feel like they are controlling a bird. There are still a few things to improve. Firstly, the sound clips have to be reloaded into the open button every time when the pitch is opened. Besides, some sounds were too loud, especially for the wind sound. Buttons can also be improved as it does not feel like the part of the bird. This is the end of my presentation for this project.